make a 0.70 moles per dm cube solution of sodium chloride in a 250 milliliter volumetric flask. The first thing you would want to get your hands on is sodium chloride. The volume of it that we are making is 250 milliliters. So what I need to get next is a flask like this one. What do you call that flask? I want someone to take the microphone and give me the proper name. Let me give a hint. It begins with a V.
A volumetric flask.
Volumetric flask.
Yes, a volumetric flask. This particular one, because my task is to make a 0.70 moles per dm cube solution and 250 milliliters of it, people don't want to make more than they need. We don't want to waste chemicals. So we're going to make exactly the amount that is required. So you get a flask like that one, 250 milliliters. When you get up close to it, you'll see it says 250 milliliters on the label. Unfortunately, this one, the manufacturer didn't pay much attention to how the M was written. That M should not be written with a capital letter. It should be written with a lowercase letter. Small letter M stands for milli in the SI unit system. Sometimes you see people don't use proper SI unit. For grams, you will write G. There's no plural of any metric unit that is accepted in the SI system. Again, things that you see on the internet are not considered acceptable for putting in your reports. The important task is to know how much mass of sodium chloride you need to put into that volumetric flask. And that is where now we would need to do some calculations to determine the mass that we need to put into the flask, so that we can go to the balance here and find the mass that we need, and then we can put it into the flask. Before we go into that, I have one more question. What's the point of this fancy flask? Why can't we just get a big beaker that says 250, or a big long graduated cylinder that says 250? Is there any point to this flask?
It's more accurate than other flasks.
Well, it's pretty much a logical answer to go with that. It's more accurate, and that's it. That is true. It is compared to if you had a beaker and you had a graduated cylinder, or a measuring cylinder, it's also called, and you had a volumetric flask, all for 250. This is going to be the #1 device to choose to get exactly 250 milliliters. But why the big bulb at the bottom? This big thing here at the bottom? What's the point of that?
Is it to like mix it easily when you're like swirling?
It is. It's deliberately put there because it's so important, Trisha. When you put your sodium chloride inside of here, that you add some water into it and you swirl it around to make sure it's dissolved properly in here. And to help you do that efficiently, you have this bulb to make it convenient for the chemist to have all of it dissolved. It's no point we are going to get all of this fancy equipment. And when we're done and you've made your water level up to 250, then you notice all of my salt wasn't dissolved. That immediately is going to cause a small amount of error, which you might think, okay, I don't need to bother about that. Well then, if that's how you're going to do your chemistry, why even bother with a volumetric flask in the first place? Having a volumetric flask means you have a very accurate tool at your disposal. But if you don't use it properly, it's not going to give you any accurate concentration. So we need to ensure that our sodium chloride is fully dissolved, or whatever the salt or the substance is that's going to be made up in here, it's dissolved in a certain amount of water first. It's all inside of solution, and then once our water level gets to the neck, we put this down, and this should be a glass bottle ideally. This is just a plastic one that I use for demo. We start filling up the water slowly, getting exactly so that the curved meniscus is at the mark, which you will see clearly on a glass bottle, where that mark is. If you exceed that mark, and you see students exceeding it, the moment you exceed it, this entire thing is useless, because you'll be exceeding by a milliliter or 2 milliliters, and that is of course going to affect the concentration. And if it is you didn't care about that little difference, why even bother with a volumetric flask in the first place? It means you are making some kind of rough solutions concentration in your solution. You are not making something that is very accurate and 0.70 moles per dm cube. Exactly. That is your goal. So you got the salt that you need, sodium chloride, you got distilled water, got your volumetric flask. Now, before we go find the mass, we don't want to just put any random mass in there. We've got to solve for the mass. And these are all of the calculations that we need to do. There's your task at the beginning. This is the equation that you need to use, the relationship. Number of moles equals to this concentration C multiplied by V. This is the concentration that you seek to get. This is the volume that you're working with, which must be converted into dm cube. That's why I always emphasize to you guys, you need to know your unit conversions. 1000 milliliters gives you 1 dm cube, which gives you also 1 liter. 1 milliliter is the same as 1 cm cube. So you hear like medical people tend to say cc's. That's not an SI unit. cc is not an SI unit, but it refers to cubic centimeters. cm cubed. ml is the unit I tend to use a lot, and you would tend to see that most in every IB document. Milliliters and dm cubed. So milliliters, 250 milliliters, 250.0. Dividing that by 1000, you get this amount of dm cubed. Then, using equation n equals c multiplied by v, which is given to you, you're supposed to know this equation. Number of moles, concentration in dm cube, moles per dm cube, multiplied by volume. You have to have the right units, otherwise you'll have the wrong answer. 0.70 moles per dm cube, multiplied by that, and you get this number of moles, 0.175 moles of sodium chloride is needed to go into this volumetric flask right here. But you can't measure this on this balance. So whenever we talk about amounts, we need to measure mass in grams so that we can take our sodium chloride and find the appropriate mass in grams. What is that appropriate mass that we would need to get the concentration that we desire? We have to use this other relationship here that we need to be familiar with, and notice n equals CV. I put that up here as well for your information. So you can manipulate and solve all of these three so that you can make anything you want the subject of the formula. What's the mass in grams? So this means when these two are lined up at the bottom, that means multiply. We're going to multiply this number of moles here by the relative formula mass of sodium chloride. Mr multiplied by N, the number of moles, you get this, 10.2375. I don't want to leave my answer with those 4 decimal places there though, because look at here, I'm given 2 decimal places, and here I'm given 4 significant figures, 4. So I've kept this at 10.24 because in any case my balance that I have here is a 2 decimal place balance. It's only going to go up to 2 decimal places. Because this is a 7 here, I make this into a 4, rounding it up. Then you have to get something like this where you're going to put your sodium chloride onto it. You notice this balance has got pieces of glass all around. What's the purpose of that? If you can't see it, but it's got a glass window here, one above, one at the side. What's the purpose of that?
So that maybe it doesn't get altered, or maybe the concentration stays the same. I don't know.
Does it make it like some sort of vacuum so it doesn't take into the air pressure into consideration?
Both answers are reasonable. It's to ensure that there are no air currents, because a balance could be a very sensitive thing. You have to ensure that if a current of air comes in, it could change the reading. So it's to prevent that, you open your window there and you put the dish that you're going to use. Then this is going to have a certain mass, not a weight, a mass. Mass is the amount of matter in the entity. Weight is about the force of gravity on that matter. The unit of weight is newtons. People, of course, in everyday English use mass and weight interchangeably. That way of knowing is something that scientists don't use, that way of knowing. We don't talk about going to find the weight of anything. Although you might see, I might get a worksheet from the internet which would say that. I would tend to say, go find the mass Other teachers would say massing something, and they use mass as a verb, that you can actually mass something. Creating that as a chemist's word. A verb in chemistry is massing. He is massing 5 grams of sodium chloride. It's a way that scientists do tend to communicate. So that's your way of knowing in science, as opposed to other ways of knowing and other ways of using the English language. Mainstream, mass and weight are seen as the same. But for scientists, for physicists, definitely, mass and weight, not the same thing. Then you have this thing here. What do you call this thing here in my hand?
Spatula?
Spatula. Spatula. And good to know what it is, so when someone says, go get a spatula, you know what you're looking for, right? That's the reason to know what something is. It's just vocabulary. Then you go scoop out some of this. Some people refer to it as a scoopula also, because you can scoop things out. And you scoop out some, and you just gently, first of all, after you've got the reading of this, you're going to press on one of these, which will get everything to 0. And then you don't have to worry about the mass of this anymore. Whatever you pour on there, you're seeking to get your 10.24 grams. Remove this, you turn everything off, and you are ready now to go to the next step. Very important is to ensure that this thing is kept level. So once you have your 10.24 grams of sodium chloride, then you need to get it into your volumetric flask, which you can do by opening up cap there, putting on a funnel, getting this in here. Again, it's no point that you're using all of this equipment to ensure that you're accurate if you're not going to follow good protocols and procedures. Get all of this in here. If you need to wash a bit off, wash it down. Wash everything from the funnel in here. Get everything in here. When you have enough in here, and this is, by the way, this is distilled deionized water, DiH2O. Have it there. Got my funnel here. Then you swirl around in here, ensuring that all of your salt is dissolved. Put this down, and you slowly add water. When you almost get to the mark, you could take a small dropping pipette, or a dropper as people call it, and slowly ensure that you don't exceed this meniscus. Your meniscus exactly touches this line. Otherwise, you're creating a bit of uncertainty that you shouldn't have. You are creating what we would refer to as a random error in your experiment. The moment that you're not really making up to this mark, and there's no excuse for that, you can avoid it. And this is your question now. Tell me how much mass you are going to need to put into your volumetric flask for this one. Share it on Hangouts.